4 satellites and a clock error Einstein predicted find you anywhere on Earth. The satellites tick 38 microseconds fast every day, and that tiny gap is why your phone works. Skip that tiny correction and GPS breaks fast. Positions go wrong within about 2 minutes. Left alone, your location drifts roughly 10 kilometers per day, enough to put you in the wrong city. So why does a clock error matter this much? Start with the trick. Your phone doesn't see the satellites. It listens to them. Each satellite broadcasts 2 things: where it is and the exact instant it sent the signal. Your phone times how long that signal took to arrive, multiplies by the speed of light and gets a distance. 1 satellite draws a sphere you're somewhere on. 2 spheres cross in a circle. 3 pin a point in 3D space. But here's the catch. Your phone's clock is cheap and slightly wrong. So it adds a 4th satellite to solve for its own clock error too. 4 signals, 1 location. Now the hard parts. That whole trick lives or dies on timing. Radio signals travel at the speed of light, about 300 meters every millionth of a second. So if a satellite's clock is off by just 1 microsecond, your position is off by 300 meters. To time signals that precisely, each satellite carries an atomic clock, accurate to billionths of a second. Regular clocks drift. These barely do. But being precise isn't enough, because those clocks have a problem no engineer can fix. Here's the twist Einstein saw coming. Up in orbit, gravity is weaker. His general relativity says a clock in weaker gravity runs faster, about 45 microseconds per day ahead of the ground. But the satellite is also racing around Earth. His special relativity says a fast-moving clock runs slow, about 7 microseconds per day behind. Subtract one from the other. The satellite clock ends up ticking 38 microseconds per day faster than yours. That's not a rounding error. Remember, 1 microsecond is 300 meters. So engineers deliberately tune each atomic clock to run slightly slow before launch, so that once it's in orbit, it ticks at exactly the right rate. Relativity pre-corrected. So how good is it really? Under open sky, a GPS smartphone is typically accurate to about 4.9 meters, roughly 16 feet according to GPS.gov. Near buildings, bridges, and trees, that gets worse as signals bounce. The system keeps improving too. A SpaceX launch on January 27, 2026 added a new GPS-3 satellite, bringing the constellation to 32. Craft that are 3 times more accurate with signals 8 times stronger than the old ones. And your phone doesn't wait around for satellites to spell out their positions from scratch. It uses cell and Wi-Fi data to grab predictions instantly. That's assisted GPS, why your dot appears the second you open a map. But GPS has a weakness. The signal from orbit is faint. Faint signals can be faked or drowned out. Fake one and a receiver believes a lie, that's spoofing. By late summer 2024, about 1,500 flights a day were being spoofed, up from around 300 a day earlier that year. In August 2025, a plane carrying European Commission President Ursula von der Leyen hit GPS jamming near Plovdiv Airport in Bulgaria and landed safely. So how do you fight a fake signal? Galileo Europe system now signs its messages cryptographically so a receiver can prove they're genuine. That service went live on July 24, 2025. Newer phones read 2 frequency bands to cut bounce errors. And modern chips track 4 systems at once. GPS, Galileo, GLONASS, Beidou, so losing one doesn't blind you. Now it all clicks. 4 satellites hand your phone the geometry. Atomic clocks hand it timing precise to billionths of a second. And Einstein's 38 microsecond correction keeps that timing honest, the one piece that makes the whole thing work. Every single time your phone drops a pin, it's silently accounting for relativity. A prediction from a 1915 chalkboard, now buried in a chip in your pocket. That's the answer. A clock error Einstein foresaw is the reason GPS can find you at all. Here's what to take away. When your dot jumps around downtown, it's not broken. Tall buildings are bouncing the signal, and no clock fix helps with that. If accuracy matters, step into the open and give it a few seconds. And that little error circle on your map isn't decoration. It's the system being honest about how sure it is, a rare piece of tech that tells you when it might be wrong. So GPS is really 3 ideas stacked: triliteration for geometry, atomic clocks for timing, and relativity to keep them true. Now hardened against spoofing. Next up, how those atomic clocks actually keep time. Subscribe and we'll open that box too.